In this section we're going to be covering chapter 4.1 to 4.2, and it's all about the properties of triangles and proving those and stuff. The first one we're going to do is the triangle sum conjecture, which says that the sum of the interior angles of a triangle equal 180 degrees. And that you probably already knew, so A plus B plus C is always going to equal 180 degrees. So that way, if you know two angles, then you also know the third. Right? Okay, but since this is geometry, we're going to have some fun and we're going to prove that. So what we're going to do first is we're going to draw two parallel lines. See, these are parallel. And we're going to stick a triangle in here. There. So that's a triangle. Angle 1, 2, 3, 4, and 5. Alright, now what we want to eventually prove is that angle 2 plus angle 4 plus angle 5 equals 180 degrees. Alright, because that would, I can't write 180, equals 180 degrees. And that would prove, the triangle sum theorem, because the three angles of the triangle. So the way we're going to do that is we're going to do a two-column proof, because those are the cool ones. Alright, and over here we're going to say that angle 1 is congruent to angle 4, because of alternate interior angles. I'll show you that really quick. Alright, so if this is two parallel lines cut by a transversal, these two are alternate interior angles and therefore are congruent. In the same way, we can say that angle 3 is congruent to angle 5. And that's also because of alternate interior angles. If you look at it, get rid of that line. Look at it this way, parallel line cut by transversal. These two are alternate interior angles. Alright, now you know that angle 2 is obviously congruent to angle 2 because it's the same angle. Alright, you know that angle 1 plus angle 2 plus angle 3 equals 180 degrees. And that's because it's a straight line, It's a straight line broken into three parts. It's, I don't know, you can't quite call it a linear pair, but sort of. So we're going to say straight line. Alright, now we're going to substitute these in. See, we know that angle 1 equals angle 4, so here we're going to sub in angle 4. Angle 4. Then here, angle 2 is congruent to angle 2, so we're going to sub in angle 2. And we know angle 3 is congruent to angle 5, so angle 5 equals 180 degrees. We can say that because of substitution. And that's exactly what we wanted to say. Angle 2 plus angle 4 plus angle 5 is 180 degrees. Okay. Now we're going to prove, or we're not going to prove it, never mind. I'm just going to talk about it. The third angle conjecture, which says that if you have two triangles and two of the angles, they share, two angles that are the same. See how both of those have that and both of those have that. We know that the third angle is going to be the same. Alright? So if you know that two angles are, you know the third. If two angles are congruent between two triangles, you know that the third angle of each triangle will also be. That was a little confusing. Alright, in an isosceles triangle, we know that two sides are congruent. And we have some parts that we name. We call this the vertex angle. We call this the base. And that and that are the base angles. And these two are the legs. Alright? Those are just kind of typical things that terms that you'll hear if you're talking about an isosceles triangle. And now, we're going to have conjecture about isosceles triangles. The isosceles triangle conjecture, which states that the base angles are congruent. So anytime you have a triangle and you know that this is congruent to this, say you know that this is 30 degrees right here, you know that these two are both going to be equal. So we're going to know that 30 plus 2x equals 180. Subtract 30. You know 2x equals 150. X equals 75 degrees. So now that both of these are 75 degrees. Also, we have the converse of the isosceles triangle conjecture. Can't spell. Isosceles. There you go. Which states that if the base angles are congruent, then it's isosceles. I've spelled isosceles different every single time here, so don't judge my spelling. So anytime you know that at least two angles are congruent, you know it's either isosceles or equilateral. And an equilateral triangle is isosceles by definition, but it could be. But anytime these two angles are equal, you also know that the legs are congruent, because that's the definition of an isosceles triangle. So yeah, I think that about covers the first part of chapter 4.